Good evening, I'm Jamie here. I'm back for part 2 on the Versa Networks videos. In these sets of videos, I wanted to continue with the lab that I built, and basically the MPLS circuit that I built last time I didn't switch on, so I want to switch that on. I want to look at the SLAs, the SLA agreements or service level agreements, and using the circuits. I want to look at introducing quality of service for the traffic flows, and I also want to look at using OSPF to learn some routes from a layer 3 switch. That's site 1, so that's what I'm looking to do today. So I shall begin. I hope you enjoy it. Okay, so we've got our Versa environment that was built. What we're going to do is we're going to build a switch at site 1. Very easy config. Just put an IP address on the interface, turn on OSPF, and then on Versa configure OSPF that side, and then check that the layer 3 switch at site 1 has learned the routes. So let's take a look at that. I'm just going to make a new project. Okay, let's have a look in GNS3. And on this box I have a cloud that is connected to my SXI server on that port, and that port is on the same network as site 1. So I'll just boot that up and we'll just test. I was going to say, yeah, I mean we can just quickly test connectivity between the sites. Let's just pull that up. Okay, so that's site 2 and rightly site 1. Okay, so let us just pop into the switch and we will give it an IP address, and then we'll turn on OSPF on that interface, and then we'll go into router OSPF1 and we'll do network. Oh, that's interesting. So establish the neighbourship with the Versa. It must be because I'd already built the configuration to test it, and I've just cleaned it all up to sort of demonstrate. Okay, so I've done that. So we do show them. So we've got a neighbour. So technically what we want to look at is committing the template. Oh, my site 2's missing. Site 1's missing, sorry. Let's just go and have a look for site 1. What's wrong with site 1? Redeploy. Let's just get him working again. I'd like to see him under here. That's better. Let's just give him a sync. So sorry about that. We shouldn't have really seen this OSPF. Neighbour shouldn't have been up. So it's my bad. They'll wait for that dead time to tick down, I guess. Slowly going. Nearly gone. Gone. Okay, brilliant. Okay, it's gone. So we got our routes of 172.16. So let's have a look at our room config. So we've added the IP address on the interface that connects to Versa Site 1. We've enabled OSPF. Let's create a loopback interface. So we do that. Okay, we've got our networks. So what we have to do here is let's make another template specifically for or including OSPF. So we just go into configuration, go to templates, device templates, and copy this template here, and we'll just do underscore OSPF. It's essentially your site type, isn't it? Okay, so we're good on that. I'll pop into that, go to virtual routers, click on the LAN interface, go into OSPF. Let's do instance 1, router ID, and add an area, network, area ID 0. We'll do network name is data for the data interface, and that's it. So I believe that should be enough. Okay, and then on the redistribution policies, we pop into the default policy to BGP and add in OSPF in there as well. Okay, so OSPF, that's it. Okay, there wasn't anything else I needed to add there. Remember, it's just my test environment. If it was your live environment, you'd be adding more than what I've just added essentially. So now we need to do redistribute to OSPF policy. Let's create one of these. So lazy. A plus on that. T1 BGP. So we're redistributing BGP to OSPF. So let's do BGP and just leave all that. Okay. I guess if you had different routes types or different communities or whatever you wanted to match on, I'll just match on BGP in my environment. Okay, so then we'll just do redistribute to OSPF. Press OK. And I think I've just missed something off, and that was the router ID. Might not work without that. Well, I won't. So I think that was OSPF. And oh no, I didn't miss it off. My bad. Okay, so now we've got to create a device template. No, sorry, create a device pool. So device groups, that's it, device groups, my bad. So let's just do this. And this is our OSPF site types. Post staging template, pick our new template there. Pop across to workflows, pick our device, site 1. And then we'll pick site type 1's device group, which will be the new OSPF device group that we've just made. I've done this before. I was sat there hanging. I was wondering what was going on. There we go. So we changed the device groups to OSPF. Bind data. If I just scroll across, I'm just going to steal this because that's my site 1 local IP address, and there's me OSPF router ID. So redeploy that. Okay, now I'm popping across commit templates, pick OSPF. I just deployed it. Find that hard. Let's just cancel that. Yeah, it's not there. I didn't think it was. Okay, so let's commit that. Normally this would say out of sync, so I'm quite surprised. No devices associated with the template. Okay, let's see how we get on. Oh, there we are. initializing, full, and there's our route to site 2, and we've also learned the default route, so let's pop off to site 2 and we'll do ping 172.16.1.1. So we can ping the Versa router at that site. We can ping the layer 3 switch. Let's also ping the loopback address, and we can ping the loopback address, which is fantastic. So one thing I would probably like to do, to be honest with you, is when we look in this routing table, we see we've actually learned a default route. That might not be the behavior you want. It probably is, to be fair, but let's just take that out. So we just pop into configuration, templates, device templates, OSPF, virtual routers, go into the LAN, prefix list. Let's just add a name, switch, so just site 1 switch. So we'll do sequence 1, we're going to deny default route. Oh, my bad. And then we're going to permit everything else. Okay, let's try that. Oh, yeah. We also need to add that into the distribution policies from redistribute to OSPF to OSPF. Pop in here and add in that prefix filter there. Let's see. That's, oh, sorry, we've got to commit the changes as well on the template. Out of sync. So that's what we should have got last time when we made the change. Let's press OK on that. Okay, let's have a look. Oh no, it's broke it. Oh, there we go. That's interesting behaviour, isn't it? You lost all your routes and then they come back. So that'll be one to remember for in your change window of a complete loss of routes and then them being injected back into the table as well. So there might be a setting for that. Okay, so that I believe covers the dynamic routing that I wanted to show. So brilliant, thank you. So now in this video I want to look at the SLA agreements and using the redundant links as well. So what I'm going to do, I'm just going to turn on my VYOS router, and in the first set of videos and when I created all the MPLS interfaces, it's hanging off this VYOS router. So once that pops up on the screen, then I'll find it and turn it on. Let's have a quick look for VYOS. Let's power on that. Okay, and we will pop it over to Versa, and what we're going to look at while that's powering on is creating a template, an application template for QoS. Normally when, or in the past when I was building these a while ago, the template just gets created automatically on the for the site. It was when I initially installed it. It was I've deleted it and messed around with it since. So I do custom one JIT and then do just quas and then just pick the associated organisation of where that policy is available. So all standard stuff, I'm not messing with any of it out the box. And if I just do deploy, one thing what I'm going to do is just to help me this evening, the previous video I'd done around the OSPF routing, I'm just going to make site 1 and 2 be part of the same device group, so there'll be no OSPF running. So every time I go to commit template, I don't have to commit each device group separately. I can just do one. So I'm just going to fix that now. I think that was site 1. I'll just change that to that. Okay, cool. And the template, so we created the template, now we need to associate that template with the application template with the template. So if I just pop up to the device template, and I think it's under services, applications, and then pick the quas, and we create, deploy, commit. See, now I can just pick both of them at the same time, much easier for me. Okay, cool. So what we should see then is, in a moment, well, we're not going to actually see anything. I'll tell you what, let's check our VYOS router is up. We should be able to check on the monitoring. And these paths, we want to see these paths go from 2 to all up is 4. Yeah, then that 4 there all needs to be jumping in the left. Back. Let's check our VYOS router and check that it's online. It is online, okay. What is down? What's down about it? It's all up. That path's just come online. It's not updated yet, I guess. We just have to be patient, but at least we can see that it is online. That's good enough for me right now. Okay, so if I pop under configuration, and we'll look, I'll tell you what, look at workflows first, sorry, and under application templates and QoS. Okay, so you can see you've got your 4 profiles, essentially your SLA profiles for your applications, and then what links to send them down. So we do, I think it is enforce, there we go. So like business critical is low packet loss rather than other than like low latency. You look at default, we can see there's no criteria that it will use any circuit. It can essentially get its hands on, and low priority, same principle as well, just high loss there. And expedite forwarding, it wants low latency and low delay variation. So we've got both our links up now. I'm going to log into pfSense. So what I'm going to show is that when we down a link, we can see the behavior for the site. So if I just pop up this, okay, and if I ping each site 101, so you got 2 milliseconds, and this side it's around 2 milliseconds. I think what we're going to do is pop into this router, my MPLS, show configuration, isn't it? Sounds like confirm show. Oh, okay, I'm in configure mode, that's why. Okay, so we've got down here a traffic policy of a 10 millisecond delay, which I'll apply to my sub interface, which is my MPLS interface here. So it's something like set, I'm just writing this in my run box and paste it in, set interfaces Ethernet ETH5 VIF 1120 traffic policy. So let's just go with that. Okay. Okay, so we want to do outbound, high latency, enter, commit. So we get on in the background. There we are, look. So we can see now we're using our MPLS link. Okay. So that's cool. If we were to shut down the internet link, now if we were to shut down the MPLS link, then we'll probably see the traffic drop, and then we'll have to re-establish the connection again. So if I go ahead and make that happen, shut down the link, and what's the best way to do it? Because, okay, hold on. Let's try this. Can we shut down here? Disable interface. Commit. There we are. We can see in the background now it's broke. So if we cancel it and then start it again, we can see we're back on the internet link. Cool. And if we just unset that comment, I think that del, and then commit. And then I don't think we're going to see anything in the background there for when the link comes back online. It's just going to carry on chugging along on that internet link. So we stop it. There we are. There's the clue what circuit that you're connected to there. That's cool. So we pop over to Versa, and I think that the traffic category, the SLA associated with ICMP, I think is business critical. So I think the way to check that is, let's just get rid of this, and let's say our circuit selection criteria is internet. That's chugging along in the background. Okay. So let's have a look. Let's look, internet. The lowest latency link, so it should be the internet then. Best effort. It's a low latency link. Let's just check this. Let's all just put them all as low latency because it makes it easier then. We'll take this out as a circuit selection. We'll just say has to be low latency, and we'll just pop across to this one. We'll do low latency. I know where I am then, across them all. Let's redeploy that. And if this doesn't show the behaviour that I want to see, then it's likely related to the fact that the ICMP is not at that top level in here, but is in one of these here, which overrides that top level there. So let's just see. So we should get best link. How's this looking on the right? Okay. That's using the MPLS still, and this is using the MPLS. So that says to me that it's not using what's in that bit, it's using something down here. I think it might be business traffic. low packet loss. Let's put low latency. Redeploy it. Commit the template. Push it to both sites. We always do that, I don't need to look at that. Let's just keep that in the background. Okay, that's done. Let's have a quick peek. There we are. It's using the internet circuit now. So it was hidden under business critical, but right at the bottom under business traffic. So that's our win there. That's what was causing it was using the low packet loss, wasn't it? So that's cool. I think while we're in here then, let's look at the load balance. No, let's have a look at the replication of the traffic. Because when we lost the link before, the ICMP stopped working. So let's just do forward error correction, replication, redeploy that, commit the template, pick the site, press OK. See where it says in sync? What I've noticed is when you make changes to the QoS policies, it doesn't actually show you there's a change to be made against the template. It's probably likely to the version of the image I'm using in my lab. So there we are, let's pop across. So we know we're using the internet link, so let's kill the internet link off. So if we go into site 1 and we'll just turn off that interface and have a quick peek. See how we get on in the background here. Look at that, lovely. It's gone from 2 milliseconds to 11 milliseconds. So yeah, that's what I wanted to look at around the SLAs. You can go into other configuration around them as well. If you click configuration here and then go into templates and service templates and pick your QoS policy. I think it's under services. Yeah. Services, SD-WAN and SLA profiles. So these are all the applications. That's what we're looking at here. So you can set the minimum and the maximum latencies and a boatload of configuration properties for each one of the profiles. It really is a lot of detail, to be honest. It's quite impressive. It does what was set. It just gives you a lot more configuration, to be honest. It's really good. So okay, I hope you enjoyed that, and I'll do a talk around the quality of service next. So following on now, we've made our application template and we've applied it to our sites. So what I want to look at now is using the traffic classes to put the traffic into the correct class. So you know, we'd have a real time, best effort, business critical, and there's a network control policy as well, which is, when I look through the documentation, it's what you kind of should put in there. So if I was to look on the templates, service templates, look at QoS and look at class of service, we see we've got the quality of service profiles that is assigned when we created the policy, and you can see we've got expedited forwarding, assured forwarding, best effort and low profile. So we're going to use essentially all of these, apart from the low profile will be network control. So if I just pop across into drop profile, and I'll just make a drop profile, so I'll just do this as a high loss, maximum of 30 packets and a minimum of 10, and if I just do add a low profile and do a maximum of 100 packets and a minimum of 1 to minimise that loss. If I go into schedulers, add, and we'll do real time. Okay, so let's do real time. High loss, low loss. Let's do, say, a percentage. You can have 10% of the traffic, and then we'll just set the weightings for each one of the queues. So I've done that one. Then we'll do the same for business critical, which is the next one down in my mind. And then 12, 11, 10, 9. Oops. On that business critical, I forgot to set the rate. So let's say we're going to give you 40% of the traffic, guarantee 40%, and only allow you to transfer 40% rate. I'm only doing that because when I do tests between the two machines, I can see it actually working and going into the correct class. Probably wouldn't have that, maybe a percentage. I don't know what it would be, top of my head. So okay, go ahead with that. We'll make another one, which is default. Okay, and they'll do high, low. Default will give you 60%, and we will configure the queues. Okay, and we want network control as well, which is the last one. Okay, let's give them 10%. Okay, and we pop into schedule maps. We'll just put the name and then associate the classes. So network control, let's say real time, business critical, and default. Okay, I think that's right. And then if we then associate to a interface, so we'll add, it's the cogs button, and then the rate, so let's just say you can only have 10 meg and a burst of that value there of bytes, and then we will pick this scheduler map of circuit. Okay, and then we will pop across to the workflows under devices, click site 1, bind data, and we've got to pick, here we are, got to pick the interface. I think it's something like that, I can never remember. Let's just cancel that, go to configuration, go to devices, site 1, look at the, there it is, VNI-0/2. So it's always right to check, always get that wrong. Site 1, bind data, redeploy, and site 2, bind data, redeploy, and then we'll commit the template. I'll sync. That's cool. So we know, I think, that business traffic, it's ICMP and it's iPerf. So for some tests now, I'm just going to use iPerf. I'll just cancel this off. I'm going to shut down my MPLS because I don't need that anymore. Where are you? Shut down. That can go. Site 1. I don't know what. Got an outage. Not good, is it? Huh. Because I didn't bring my interface back up. What a silly. Okay. There we go, back in business. Recovers quite quick, that, to be fair. I'm bringing up the tunnels. I'm impressed with that. Okay, so let's check the traffic class that's slipping into. So we pop across to Versa, go into monitor, go into devices, go into customer, devices, site 1. And then I think costs over here. Is that like quality service profiles? I can't remember which one it is. Oh, interfaces. And then assured forwarding. I think that's it. So if we look at app policies, default policy, business traffic, see 56. None of the others have got any hits. Let's test this. Let's do an iPerf free server, that side. This side, iPerf -c 172.16.1.101. Interval of 1 second and time for 10. Oh, it's iPerf free. Let's give it a go. So we are, we're looking at just under 4 meg. So we know, because we put 10 meg shaping on the circuit and we're getting 4 meg, then we know we're hitting the 40% class. Sorry, 4%, 40%. I can't find it. Hold on, where is it? Can't say it. Templates, service templates, CORS, class of service, schedulers. That's it. So in the scheduler, we set business critical 40%. So it shows we are actually using that policy there, and we can see the burst kicking in as well. Okay, at the beginning, so I quite like that. That's quite cool. It's like giving it 12 meg to begin with and then dropping it back down to 4. So that's cool as well. So yeah, that's pretty much it that I wanted to show around the schedulers and around the quality service profiles and the learning of the OSPF routes and the SLA for the links, using the redundant links. So hope you enjoyed that, and thanks very much.